Alrighty, so let's start our 9th day after calculus. Okay, whoops, that's not it. Where are we going? We're going here. Okay. Alright, kindly consider the following. Let's say, number 1. Let's say you want to solve s prime equals s. Now this is variable separable. We've solved this kind of a problem before. But let's say we don't want to integrate. Is there another way? Here's some initial conditions too, by the way. Well, if there is a solution function s of t, there's probably a power series for it. Let's make it easy. What if s is a Maclaurin series? All right, so let s equal some constant plus some constant t plus some constant t squared, and so forth. All right, let's say that's enough. Okay, well, the differential equation says that s, the solution, equals s prime, its derivative. So now we know the answer to that, don't we? But let's pretend we don't. And what's the derivative? Just using the power rule. So we're not integrating to solve the differential equation now. We're differentiating, actually. All right, so we're not anti-differentiating, we're differentiating. All right, so the derivative of a is 0, that's a constant. Derivative of bt is b. There's just power rule for derivatives, and plus 2ct plus 3dt squared plus 4et cubed plus 5ft4 plus. Okay, well, let me clean that up a little bit. And that's just a t to the 4th. Okay, now look at the initial conditions. What if we plug into the s expression t equals 0 and s equals 1? Well, all the t terms drop out to 0, and a equals s, which is 1. All right, good. Then s equals s prime. So let's make these two expressions equal term for term. Like, let's see, b equal to a, the first two terms, but a is 1, so b is 1. All right. 2c equals b, but b is 1, so c is a half. Okay. 3d is equal to c then. The coefficients have to match for the t squared terms. So 3d is a half, so d is a sixth. Let's see. This was over 1, this was over 2, this is over 3. I multiplied the denominator 1 by 2 and I got 2. I multiplied the denominator 2 by 3 and I got 6. 4e equals d, but d is 1/6, and I multiplied the 6 by 4. This sounds like a factorial. And 5f equals e, so 5f is 1/24th, so f is 1 over 120, and so what do we get? We get that, let's just bring this down a little bit, or bring it up, as the case may be. Okay, so the solution is s is a function of t, is a, which is 1, plus bt, which is 1t, plus ct squared, which is 1/2 t squared, and 1/6 t cubed, and 1/24th t to the 4th, and t to the 5th over 120. There you go. Isn't that the Maclaurin expansion for e to the t? I think it is. All right, so notice we didn't do any variable separating. We didn't do any anti-differentiating. We just differentiated. We knew to use initial conditions and whatnot, but that's okay. All right, try that again. Number 2. Let's see, number 2. Let's go back up. All right, so number 2 says, let me give you this one. What if s prime is the opposite of s, and s of 0 is 1? Well, let's do the same thing. Let s equal a plus bt plus ct squared plus dt cubed plus e t to the 4th plus f t to the 5th. Okay, that should be enough. And s prime is therefore b plus 2ct plus 3dt squared plus 4et cubed plus 5ft to the 4th. Forever, infinitely long power series, okay? All right, and let's see. Well, if s prime equals negative s, then b is the opposite of a. But again, a is 1. So b is negative 1. Oh, what happened there? So b is negative 1. Okay. Now 2c is going to be negative b. But b is negative 1, so 2c is positive 1, c is 1/2. Okay. 3d is the opposite of c, right? Because s prime is the opposite of s. And we're matching the coefficients of the t term and the t squared term and the t cubed term. So 3d is the opposite of c, which makes it -1/2, so d is -1/6. We're getting the same kind of coefficients as last time, but alternating in sign. Does that sound familiar? All right. 4e equals d, sorry, the opposite of d. I'll clean that up a little bit. Hang on. Let's do that again. Is the, whoa, what happened there? Is the opposite of d. So the opposite of -1/6 is +1/6. And e is 1/24. And once again, 5f is the opposite of e, and e is 1/24, so 5f is -1/24, so f is -1/120. Good. So now what do we get? Alrighty. So s of t is, let's see, 1 minus t, because b is -1, plus t squared over 2, because c is 1/2, minus t cubed over 6. So again, we got the factorials down here. Plus t to the 4th over 24, because e is 24, and e is the coefficient from t to the 4th in the original expression for s. And what else? Minus t to the 5th over 120, plus forever. And isn't that the same as e to the t's expansion? Maclaurin expansion, so that you're replacing all the t's with negative t's? Yes, I think that's what that is. Now, sometimes you can't see a pattern, you can't recognize the function we're talking about, but here we can. Okay, good. And sometimes there's no closed-form algebraic answer for the antiderivative, but there you go. All right, how about this one? These are all first-order variable separable differential equations for s a function of t. All right, let's try another one. Number 3. We'll confirm these with Sage, too. All right, 3 says, what if s prime is 1/1 plus t, and s of 0 is 0? Okay. So let's start like we did before. Let's see, S is a Maclaurin series of some sort. We just got to figure out the coefficients A, B, C, D, E, and F. So plus BT, plus CT squared, plus DT cubed, plus ET to the 4th, plus FT to the 5th, plus. We might need more terms sometimes. Get a pattern? So let's see. We want S prime to equal 1/1 plus T. Well, let's get an expression for S prime then. B plus 2CT plus 3DT squared plus 4ET cubed plus 5F T to the 4th plus. But now we have to make that expression equal to an expression for 1/1 plus T. Isn't there a power series for this? Doesn't this look geometric? Where A, the first term, is 1, and R, the common ratio, is -t. So 1/1 plus T can be written as this Maclaurin expansion. 1 times -t times -t times -t times -t. Okay. So let's say these two terms are equal. And if you, by the way, if you plug in 0 for t in the first expression for s, and s equals 0, then a equals 0, right? And then we have that the first two terms in s prime and 1/1 plus t are equal. So b equals 1. And 2c, whoops, what happened to my pen? Whoops, there you go. And 2c equals -1, so c is -1/2. Okay. And 3d, the coefficient in front of t squared, right, equals 1, so d is a third. And the coefficients in front of the t cubed terms of the last two equations have to match, so 4e equals -1 makes e equal to -1/4. Notice these denominators are not factorial. This sounds like, didn't we do an expansion like that that was logarithmic? Let's see. If that makes sense. And f equals 1/5, and so forth. All right, so let's write out what we got. Let's fill in A, B, C, D, E, and F in the original expression for S, and that's our final answer, Regis. So S of t is, well, A is 0, and then you have B is 1, so 1t, and C is negative 1/2, so minus t squared over 2, and plus t cubed over 3, yep, and minus t to the 4th over 4, and plus t to the 5th over 5, and so forth. Okay? So I'm thinking this may be logarithmic. Didn't we encounter this when we expanded logs using Taylor's theorem? Or maybe even arctans? We'll check that out in Sage, but if you variable separate this, right, go back to the beginning, ds dt, cross multiply, well, multiply by dt, and you're integrating 1 over 1 plus t dt is ln absolute 1 plus t. Yeah, this is ln. Okay, good. Alrighty, so sometimes you can get the function, sometimes you don't, but you get the power series, so that's all you need. What about second order differential equations? Can you do them with this method? Let's see. 4 says s double prime is negative s, let's say. Now I need two initial conditions here for second order, so how about s of 0 is 1, and s prime at 0 is 0. And let's start the same way. Let s be Maclaurin. Now I think I need more terms because I think a lot of these terms are going to zero out. So let me throw in an extra term. How about a plus bt plus ct squared plus dt cubed plus et to the 4th plus ft to the 5th plus gt to the 6th plus. Alrighty, and so let's say I need s double prime to equal negative s. Well, there's s, so I can take the opposite of that, but I need s double prime. So first let's get s prime. b plus 2ct plus 3dt squared plus 4et cubed plus 5ft4 plus 6gt to the 5th. And I need s double prime, so do it again. Well, the derivative of b is 0. Derivative of 2ct is 2c. Notice I'm lining up the 0 degree terms and the first degree terms and the second degree terms to make it easy. Then you get plus, what do you get? 6dt plus 12e t squared plus 20ft cubed plus 30gt to the 4th. All right, let's see the initial conditions. S of 0 equals 1 makes a 1. S prime at 0 equals 0 makes b 0. Okay, and now s double prime equals negative s, so 2c is negative a, or 2c is negative 1, so c is negative 1/2. All right, so we got a is 1, b is 0, c is negative 1/2. Good. Then 6d equals negative b, but b is 0, so d is 0. Okay. 12e is negative c, but c is negative 1/2, so 12e is positive 1/2, so e is a 24th. So these look like some factorials again, but it's skipping. Does that sound familiar? Skipping some, right? We used to have a 1/6 in between the 1/2 and the 1/4, right? How about 20f is negative d, but d was 0, so f is 0. And 30g is negative e, right? Okay, but e is a 24th, so 30g is negative 1/24th makes 30, whoops, let me fix that. 30g, where did that go? 30, whoa, I did it again. What happened there? 30g equals negative 1/24, so g is negative 1 over, what is that? 720, isn't it? Okay, good. So let's fill in the coefficients in S, and you get S is a function of t. Oh boy, it's getting messy. Sorry. Okay, is A, which is 1, plus BT, but B is 0, so that drops out, plus CT, so minus T squared over 2, then D is 0, so no cubic term, plus ET to the 4th, so plus t to the fourth over 24, and then f is 0, so no fifth degree term, plus or minus 1/720th of t to the sixth, plus, and you know this is Maclaurin expansion, don't you? Even powers, and then the denominator is 2 factorial, 4 factorial, 6 factorial, and alternating signs. Isn't this cosine? This is one of the solutions we got from second order differential equations the other day anyway, right? Sounds familiar? Okay. What if we perturb the system a little bit? Let's call that 4a. How about 4b? Let's change 4b a little bit. Do the same differential equation with different initial conditions. How about s of 0 is 0 and s prime of 0 is 1? Let's try that. All right, so here's 4b. All right, let's do the same thing. S double prime is negative s, just like before. S of 0 is 0, that's different. S prime at 0 is 1, that's different. Okay. Let's do the whole same thing all over again and see what happens. S equals a plus bt plus ct squared plus dt cubed plus et to the fourth plus ft to the fifth plus gt to the sixth, right? Okay. So S prime is going to be b plus 2ct plus 3dt squared plus 4et cubed. That's a 3. Plus 5ft to the fourth plus 6g to the fifth plus. And S double prime is 2c plus 6dt plus 12et squared plus 20ft cubed plus 30g t to the fourth plus. And again, by initial conditions, a is 0, b is 1, and 2c is negative a, but a is 0, so c is 0. And 6d is negative b, but b is 1, so d is negative 1/6. And 12e is the opposite of c, but c is 0, so e is 0. And 20f is the opposite of d, but d is negative 1/6, so 20f is positive 1/6, and so f is 1 over 120. And 30g is e, or the opposite of e, I should say, but e is 0, so g drops out. So let's rewrite that answer. Let's see. A is 0 plus bt, b is 1, so it's t. And then c is 0, so minus t cubed over 6. And e is 0 plus t to the fifth over 120. And again, you get alternating signs. Let me clean that up a little bit. What was it? Plus t to the fifth over 120 minus stuff, right? And isn't that just sine? You know the Maclaurin expansion for sine, right? Okay, sometimes it's recognizable, sometimes it's not, but there you go. All right, one more like that. What if it's not even variable separable? What about this? What if, let's start at the top, S prime, this is number, I guess, 5, we had 4a, 4b, and 5, right, is t plus s. Remember we did this on the subfield, dy dx was x plus y, something like that, right? That's not variable separable, is it? It's first order, though, so I need at least one initial condition. There you go. And let's do what we've been doing. Okay, so S equals A plus B T plus C T squared plus DT cubed plus E T to the fourth plus F T to the fifth. That's probably enough. Second order, I need more. Well, especially if we drop out every other term like we did. All right, so what's S prime? Let's see, I want S prime to equal T plus S. Huh? All right, so I need both of these lines. So that's b plus 2ct plus 3dt squared plus 4et cubed plus 5ft to the fourth plus, okay, good. Initial conditions makes a equals 0. And so, and then b equals, well, if you add t to s, it only affects the bt term, right? So b is equal to a, so b is 0. Okay. But 2c equals b plus another t, right? bt plus 1t. All right, but b is 0, so 2c is 1, makes c a half. All right. Then 3c, now this, the t squared term doesn't get affected when you add t, right? It's not a like term. So 3d equals c, and c is a half, so c is a sixth. All right, then 4e equals d, but d, whoops, what happened there? This is a d. Whoa, back up. This is 3d, and this is d, sorry. 3d and d. Now, these are 6, so 4e is 1/6, so e is 1 over 24. So this looks like factorials again in the denominators, huh? And 5f equals e, but e is a 24th, so 5f equals 1/24 makes f equal to 1 over 120. Alrighty. So let's see what we get. Let's see. So s of t is, let's see, a and b dropped out. They're both 0, right? So start with c, 1/2 t squared. Okay, so t squared over 2 plus t cubed over 6, 3 factorial, plus t to the fourth over 24, e t to the fourth, yeah, plus t to the fifth over 120, plus, doesn't this sound familiar? This is the same as the Maclaurin expansion for e to the t, missing the first two terms. There you go. And again, you don't have to recognize the function. Okay, let's confirm this stuff on Sage. Here we go. Let's try this on Sage. All right, so let's switch gears. Let's do the same 6 questions using Sage. So let me save that. And let's go over to Sage. There we go. All right, let's make a new worksheet. Let's call it let's see. Okay, we had LAC 9 yesterday. We didn't do Sage. I'm going to call this LAC 09A, Power Series Solutions to Differential Equations. How about that? Well, I'll leave it like that. And my name. And the date. Today is, what, the 12th? Okay. All right, so number 1 was s prime equal to s and s sub 0 equal to 1. So now I want s as a function of t. So how about we var t, and we defined s as a function, s of t. All right, let's do a DE solve. Show the DE solve for, let's see, s prime minus s equals 0. Okay, so the diff of s with respect to t, first derivative, minus s, and let's solve it for s. So the general solution is, what I do? Oh, I forgot the close for the show. I always do that. And there's your general solution. Didn't we say that our particular solution was e to the t, in fact? So let's throw in some initial conditions. Let's show this with initial conditions. And what are they? 0, 1, okay. So comma, square bracket, t is 0 when s is 1. And so is c, is the constant c 1? It is. Very nice. And just for fun, how about we show the Taylor expansion for e to the t near 0, with respect to t near 0, so it's really Maclaurin. Well, and I think we had a fifth degree. Let's see. And the show again. And that's what we wrote, I think. Let's see. Where is that? This is number 1. Let's go back to number 1. And here's number 1. And that's what we wrote, right? E to the t, and there it is, right? Perfect. Okay. And just for fun, we could graph it. Plot, DE solve. Well, let's just copy this. Zing. And you should see an e to the x curve. Or e to the t curve. And there's an exponential growth curve. Perfect. All right, very nice. Alrighty. Number 2. Number 2 is almost the same thing, except it's s prime is negative s when s of 0 is 1. So how about we just copy this whole thing and put it in another cell. I think we got e to the negative t, right? And this. So what are we changing? Well, I guess we don't have to do this again. And now we're doing plus here and here. And I'm thinking it's e to the negative t. So how about we write that? And plus here. See, e to the negative t, e to the negative t. Those are the terms we got. We just plugged in negative t for the e to the t expansion. There's an exponential decay curve. So 1 and 2 are very similar. Oh, oops, let's call it 2. Alrighty, good. How about, let's see, number 3. Number 3, oh yeah, number 3 said, all right, let's start from scratch with 3. Number 3 was s prime equaled 1 over 1 plus t, right? And s of 0 is 0. Okay, so show the DE solve of the diff of s with respect to t, first derivative. Whoa, what's that? And we're setting that equal to 0, so minus 1 over quantity 1 plus t. Okay, good. And we'll solve that for s and see what we get. I did it again. And we do get some kind of a log, like we said. Okay, good. Now let's throw in the initial condition. So we'll copy this. Put it here with the initial condition. I think t was 0 and s was 0, right? And yeah, log of t plus 1, like we said, if we did a variable separable and integrated. All right, very nice. How about let's show a Taylor expansion for that. The show of the Taylor of the log of the absolute value of 1 plus t with respect to t near 0, so it's Maclaurin, not Taylor really. And I think we only did 5th degree term, right? And I did it again. I keep on doing this. And that's what we wrote, right? Let's take a look at number 3. Let's see, that was 1. There's 2. There's 3. T minus t squared over 2 plus t cubed over 3. T minus t squared over 2 plus t cubed over 3. Yeah, that's it, right there, perfect. And if you want to see what that looks like, let's graph it. So how about we do a plot of the DE solve. If I have to change x min, x max, whatnot, I can, but I don't think I need to. Is that sufficient? That's a log curve. Yeah, it goes through 0, 0. Slope of, right, it goes through 0, 0. That's nice, perfect. All right, how about 4a and 4b, the second order differential equation? Let's see here. All right, 4a. Or 4a gave me, what was it, cosine? I think. Let's see. All right, number 4a, let's say. S double prime equals negative s. So when we set it equal to 0, it's s double prime plus s equals 0, right? Now we need two initial conditions. We had s of 0 was 1, just like a cosine, right? And s prime at 0 is 0, Again, just like a cosine, right? Okay. So show the DE solve of the diff of s with respect to t second derivative plus s with respect to s. Close the DE solve, close the show, and do we get something to do with cosine? Well, these are solutions we got from second order differential equations last time, right? All right, let's throw an initial condition. What is it? When t is 0, s is 1, and s prime is 0. So 0, 1, 0. So put it right here, comma, square bracket, 0, comma, 1, comma, 0. Whoops, square bracket. And what'd I do? I did something foolish. What is it? Show DE solve diff st2 plus that, comma, s, comma. Oh, what happened there? What is that? 0. And it is cosine. Good, there you go. And just for fun, let's show the Taylor expansion. I think we did go to a 6th degree on this one, right? So of the cosine of t with respect to t near 0, so it's really Taylor, not Taylor, of Maclaurin. And how about a 6th degree? And let's close the Taylor, and let's close the show, and we get what we expected, yes. Even powers, alternating signs, and skipping factorials. That's exactly what we had by hand. Oh, we're so good at this. And let's graph that solution, see that it looks like a cosine. All right, how about, let's change the x min, x max, make it obvious from 0 to 2 pi, something like that. So, plot the DE solve. But I don't want to go from -1 radian to 1 radian, which is the default x min, x max, and we're in radians here. So let's go from 0 to 2 times pi. Explicit multiply, don't forget. And close that. Let's graph it. Does it look like a cosine? And it does. 1 whole period of a cosine. Very good. All right, now 4a and 4b were almost identical. So let me copy 4a, just like 1 and 2. All righty. Let's call it 4b. The difference being the initial conditions. And if it's sine, remember that s of 0 is 0 and s prime of 0 is 1. All right, let's just double check all this stuff. So s of 0 is 0, and s prime of 0 is 1. Okay, so show the ESO, second derivative, plus that's correct. But now the initial condition is 0, 0, 1. So we think it's sine, and let's see that that's what we get. Did it change everything? Yep, that's expansion for sine. There's a sine, 1 period, perfect. All right, the last one, the 6th one, which we called number 5, was not variable separable, but it was back to first order. Number 5 says s prime is equal to x, t plus s, and s of 0 is 0. Okay, so show the DE solve of the diff of s comma t comma 1 minus t minus s. Okay, minus t, remember we have to set it equal to 0, minus s for s. Close the DE solve, close the show, and you get something to do with e to the t. Didn't we say it was e to the t minus 1, something like that, right? Okay. The initial conditions are now 0, 0, so let's plug that in. Okay, comma, square bracket 0, comma 0, square bracket. Let's see what that looks like. That's exactly what we guessed. Amazing. All right, let's do a Taylor. For that, just for fun, show the Taylor expansion for e to the t minus t minus 1 with respect to t near 0, and I think we only did 5th degree here, right? And whoops, again I did it. And that's it. It was missing the t term and the 1 term. Perfect. This is just e to the t's expansion otherwise. And graph it. Plot the solution. See if that's, well, let's see what it looks like. I don't know what that looks like. Let's plot this. And it looks weird. Okay, perfect, very nice. All right, so there's 5, there's 4b, there's 4a, there's 3, there's 2, there's 1. So you don't have to integrate, and you don't have the variables separate. Alrighty, let's save that. And let's minimize this. Let's minimize this. And that's enough for today. Bye, YouTube. No, bye, YouTube. Huh? All right, bye, YouTube this way. See ya.